All right, good evening. So you are needing help on 4.2 and 4.3. So I've provided you the notes for some examples. So if we go to lesson 4.2, now it's on the back side here, but this is where we have the examples. Basically, it's having you write the rules. So the rules. So each function table has its own set of rules. So the output, which is y, is 5 less than the input. So y equals x minus 5. It's pretty simple, right? The output is the square of the input. So y equals x squared. So these are all linear equations because we have y equals x. Okay? So looking right here at number 2, we're going to substitute 3 for x. So what is the value of y when 2x plus 5? So, well, we're going to put the 3 in here. So that gives us 6 plus 5, right? Which is what they've done here. Always put this number in parentheses, whether it's positive or negative. So for example, right here, this says x is y, 5. So y equals 4 times 5 minus 1. So 20 minus 1 is y equals 19. Okay? Y equals 10 times 5. Y equals 50. Y equals 7 minus 3 times 5. So that's 7 minus 15. Y equals negative 8. Okay? Looking right here. Graphing a function. Yes, you are going to have to do some graphing. So, can we write an equation? That's the question. Yes, we can. Because our input is 0 and our output is 1. Oh, look at that. Output is 1, which is the y-intercept. Okay? So, from this, there's a 2 gap, and it's going negative. So, minus 2, minus 2, minus 2, that's our slope. So y equals our negative 2 slope, which is the difference between the two. And then right here we were doing plus 1. So x plus 1. By doing that, we're able to find that 0 is 1. If we did not have 0, we could have added 1 or subtracted 1 till we got to 0. And as long as we followed the pattern here every 2, then we would have been correct and we could have found that y-intercept. However, we were able to find it. It was already provided. Okay. So this is important right here. Knowing all of this in the summary, your input-output table, the mapping diagram, and the graph. So we've done these, and we've done these. So now the point in the object is that we are able to combine all three of these. So if you have this, you could still graph. If you have this, you can graph. If we have this, we can get the mapping diagram. If we have this, we can get the input-output table. So that's kind of the goal of that. So, and we can see what the y-intercept is, right? And we see that it's a 1-to-1 ratio, plus 1, plus 1, plus 1. So your equation of y equals x plus 2, right? Which is also what's listed right there. But I wanted you to be able to see it. Okay, same thing here. X has 0, so our y input is 3. We have a positive 2. So your equation would be y equals 2x plus 3. So they want you to determine the error between the two. So that is the equation of that graph right there in the data table. Okay, we've got a slope of 1. Slope here is 1. Slope's negative 2. I was going to say we got to match them. I was like, wait a minute. Match the graphs. Well, as you can see, these two match. Right? And so which one doesn't have a number after it? Exactly. So 29 is A, 28 is C, and B. Because this can be written also as y equals x over 3 plus 0. This really should be written as 1/3 x. So again, so 3 ways to look at something now. Okay, let's look at the exercises now. So it says write an equation that describes the function. We have our 0, right? Okay. So y equals, so right here we have plus 4, right? Plus 4, plus 4. So 4x plus 0, or y equals 4x. Either answer is correct. Okay. So do we have the 0 here? Nope, we don't. But we know if we subtract 1, because these are all plus 1, so minus 1 gives us 0, right? And these are all plus 1. So 1 take away 8 gives us 7. So y equals, we got a plus 1, so x, and our 7's plus 7. That is our slope. Okay, we have a 1 and a 0, but do we have the 1 and the 0 in the right spot? No, we need our 0 here. Okay, so we're missing a 2 and a 4 and a 6. It counts every other one. So does this one, does it not? Because there's 1 to 0, 2 to negative 1, 3 to negative 2, 4 to negative 3, 5 to negative 4. So we have a negative slope. Okay, so if we continue going, 0 becomes 1. And it's the first positive. So our equation becomes y equals negative x plus 1. And that's all we got to do. So 7 through 12. So the output, see, output. So the output is half the input. Okay. So these are all going to be y equals because is our equals, y equals. Now you take the words and what does it mean? Okay, here we are. We're finding the value of x. So this is 3. So y equals 8. Here we go. Let's see. Let's go with negative 5. So 7 times negative 5. Y equals negative 35. Okay. Y equals 9. So 1 minus 2 times 9. So that's 18. So that's y equals negative 17. Okay. I did 3. You can do the other 3. So graph the function. Well, the slope is 1. So our m is 1 and our b is 4. Okay. Our y is 2. Or sorry, our m is 2 and our b is 0. Same thing right here. Our m is 1/4. Our b is 0. Okay. So if it's where the x is, remember y equals mx plus b. Okay. So day 2 worksheet that was supposed to go with that. Right here, you're doing the same thing. Write the equation. We have 0 and we have 0. So you can write the equation. There's 2 different ways to write this one, right? Because they're both 0, which goes to the origin. The output is your y equals, right? Okay. So 8 less than the input. Input, 8 less, right? Okay. Same thing here. 5 for x. So y equals 5 minus 8. So y equals negative 3. That's it, folks. Again, graphing y equals mx plus b. Y-intercept, slope. So your y is 1 and your b, your m. Your m is 1, your b is 5. Okay. And 13 and 14 are extra credit. Okay, looking at 4.3. Basically some examples for you to plot the points. You'll see the patterns. Same thing here. Relating to those points and patterns and how they all lead to linear equations. So here we have our change in y over change in x. We're able to find our slope. Same thing on the second one, talking about change in y to find the slope. Change in y, change in x. Now we have it in a real world format. So I have more examples. Here it shows what the change is. Okay, so those examples are there for you to fall back on, look at. Sometimes on day 2, we'll come back and look at those. So right here, same thing we were doing over here. The table shows a familiar linear pattern from geometry. Write a function that relates to y to x. What do the variables x and y represent? Graph the function. Okay, well, so if we have 0, because we've got a plus 1, right? And we have plus 1 pi. So we're going to have negative 1 pi. Okay. So the function of x, y equals pi x minus 1 pi. So I can see where you guys would need some help, and the pi whole thing is confusing there. So again, we've got plus 2, plus 1. So 0 gets us 0. So y equals 2x, or y equals 2x plus 0. Okay. So now we have to 5, 6, and 7. Use the graph or table to write a linear function that relates to x and y. Determine whether the graph of the linear function is increasing or decreasing or constant. Okay. Well, it's increasing, right? So it's increasing. And it's constant, right? Or maybe they want to say that this is constant. So it's just increasing. Whereas this one is decreasing. Plus we can see it right here. And this one is just constant. Number 11 is extra credit. So number 1, 2, 3, and 4. Is it increasing, decreasing, or constant? Well, this should be able to give you a hint what that one is. And the same thing here. Okay, if you need to, graph them out. What does it look like? Okay, so actually 5 and 6, that's all going to be extra credit right there. So that's as much help as I can give you guys. So I wish I could be there in person, but I can't. So if you still have questions, please email me. I look forward to seeing you guys on Zoom. Have a great weekend.